Hello, everyone. Welcome to Cardano Live today. I have Dr. Ben Goertzel on, and Ben is the CEO and founder of Singularity Net, a project combining artificial intelligence and blockchain to democratize access to artificial intelligence. He was the director of research of the Machine Intelligence Research Institute. He is also chief scientist and chairman of AI software company Novamente LLC, chairman of OpenCog Foundation, and advisor to Singularity University. Ben was the chief scientist of Hanson Robotics, the company that created Sophia the robot, one of the subjects we'll be talking about today. And Ben has appeared on Joe Rogan's podcast, TED Talks, and many other prestigious media outlets. And thank you, Ben, for coming on Cardano Live today. It is an honor to have you here. How are you doing today, sir?
I'm doing awesome, and it's a pleasure to be here.
All right. Well, thank you so much for being here. And you're calling in from beautiful Washington State, a place I've visited a few times in the last 10 years. And the natural beauty of that state is amazing. So I hope you're enjoying it up there.
It's fantastic. After 9 years based in Hong Kong, the peculiarities of COVID travel have left me here for the last year, and I've been enjoying the cool weather and the emptiness of rural Washington State. Very amazing place to think deep thoughts about AI and blockchain and enjoy the outdoors.
Yeah, that's what I did when I was there. Enjoyed the outdoors. I got to visit Mount Rainier. I went up to what's called Paradise. I was there in May. Flowers were blooming. It was absolutely stunningly beautiful nature up there. I got to go to Hurricane Ridge in the late fall. I went down to, it wasn't like a rainforest, but there were forests up there near the lakes. Beautiful place.
There's rainforests. There's rainforests out on the Olympic Peninsula on the other side of Seattle, actually. So
yeah, that's where I was.
You got to check them out. Check them out next time. But yeah, the beauty of the internet, of course, is it doesn't matter if I'm sitting in Hong Kong or rural Washington State. Like Singularity Net team is all over the planet. Cardano team is all over the planet, and we're able to build amazing stuff no matter where we are.
Yeah, that's great. It keeps us connected. We have all these apps on the internet to help keep us connected and getting information out and collaborating, and it's just fantastic stuff. All right, so we're here today to talk about a few things. The main things were Ben's history with artificial intelligence, where you first learned of it, and then bringing that to where we are today, interacting with Cardano. We're going to be talking about Sophia and stuff like that. There's a lot of questions that have come up from people since I put out the announcement of this podcast, and people are really interested about the synergies between Cardano and Singularity. Now, I think that would be best saved for maybe a podcast with Ben and Charles as the visionaries of those projects, and they can have a nice, long, indefinite podcast because there are so many synergies to be had. But so I did kind of want to ask one overarching question that Ben can speak with us about today. And that is, why Cardano? Why would Singularity pick Cardano over ETH 2.0 or shift from Ethereum? Ben, do you have some comments on that, please, sir?
Yeah, I mean, my original affinity for Cardano actually came about just because of Cardano's use of the Haskell programming language, which is kind of a surface level point. But I was an avid Haskell developer like a long time ago, 93, 94, 95, when Haskell was quite young. And it seemed to me, at that point, this was the future of programming, and now Haskell is a better known language. But seeing that someone was building a blockchain and associated tool set based on Haskell, that told me these people somehow had their heads screwed on in the right direction, because functional programming, and Haskell is a beautiful functional programming language. I mean, functional programming has some very favorable properties for blockchain. I mean, you can write close to bug-free code in a functional programming language, which is what you want for, say, something like a global financial infrastructure, right? And you can tractably prove that your algorithms are doing what they're supposed to do and specified to do, which again is is highly favorable for something like the global infrastructure of the world economy. So seeing the use of Haskell got me interested. Then when I dug further into Cardano, I could see that like an insane list of intellectual greats from the functional programming community were collaborating with IOHK somehow. And I mean, I knew these names from the 90s when I first got into functional programming. So it seemed like there's an intellectual meeting of the minds there. And then when I dug further into the code base and the research behind it, I mean, it seemed Cardano actually is a very solid project in terms of the computer science behind what's being built, in terms of the software architecture wrapping up the computer science. And when you look at the roadmap, I mean, step by step, the Cardano community seemed to be building what actually needs to be built to make, what Vitalik had called a world computer. Because I love the vision underlying Ethereum of using smart contracts to make a world computer that can run any kind of software in a global and decentralized way. And, I myself had that vision in the 90s and early aughts, but didn't have the software to execute it. Ethereum is an interesting step, but the Ethereum infrastructure is not as robust, efficient, or elegant and well designed as one would like. And it's also not that easy to update or improve, which is what we're seeing with the long, painful struggle toward Ethereum 2.0. So I think, I mean, on a technical level, Cardano just does it better. I mean, of course, Ethereum is really cool and it has a lot of market traction, which is amazing. But I don't think it's as strong on a pure technical level. So that's what drove me in the Cardano direction, is my sort of training as a mathematician and my taste for functional programming. Then when I met Charles Hoskinson, and we hit it off fairly well on a personal level, very well, I'd say. And I mean, then I could see there's some shared social vision even beyond the computer science synergy. So I was amazed when I first met Charles at a conference in Hong Kong. We both had offices and initiatives in Addis Ababa in Ethiopia. Like what's the chance of that, right? And so now the Ethiopia team that Singularity Net works with, which is in a company called ICOG Labs that I co-founded in Addis in 2014. ICOG Labs is now sharing office space with IOHK's Addis Ababa team, and so that was interesting. And again, the fact that we're both in Addis is kind of a fluke, but the fact that we're both interested in using decentralized technology to allow Africa to leapfrog into the future, I mean, that's a deeper point, right? It's about using these advanced technologies for global democratization and decentralization, which is important to both Charles and myself.
Okay. Well, that's good to hear. So it's like the formal verification and all the high assurance code work that's been done on Cardano has kind of provided a platform that is more conducive to artificial intelligence and the Singularity Net work that's going on. And, it just proves again that great minds think alike. As you were involved with Haskell early on, and now here we are, it's starting to converge. The technologies are starting to converge, and there's probably some synergies there.
Yeah, I mean,
that are
the
going to lead
model
to all
of
kinds of stuff.
Bitcoin was in math we trust, right? And I mean, I think both Cardano and Singularity Net and OpenCog and my various AI projects, they're all following from that premise. I think that Charles and I both place a lot of faith in elegant mathematics to serve as the kernel of systems that can be powerful in the real world.
Wow. Yeah, and math can pretty much, you can almost represent anything in nature, anything that people are doing with math in some way, shape, or form, which it kind of leads us back to one of the things that we wanted to talk about on this podcast was, let's go take a trip down memory lane. What was your first exposure to AI when you were younger? What were the first things you identified as AI, and what kind of led you down the path of
So
artificial intelligence?
I'm an old man. I'm a grandfather. I'm 54 years old. So in my generation, our first exposure to AI was in science fiction, because AI as a practical pursuit existed, but was pretty small time. So I mean, there was Star Trek with the occasional robot on it. There's Space 1999. There was HAL 9000 in Stanley Kubrick's film 2001: A Space Odyssey, and then after that, there's a host of science fiction stories and novels, right? I mean, there's Asimov and Heinlein and so forth, and all that was my introduction to AI. And so growing up, AI was one of those science fiction things like space-time reengineering, time travel, and psychic powers and so forth.
Yeah,
I didn't start to think about AI as a practical sort of pursuit or career move until maybe in 1979 or 80, when I encountered Douglas Hofstadter's book, Gödel, Escher, Bach, which is a beautiful philosophical and literary work, but it was also my introduction to the academic AI world and to what real life AI researchers were working on. Then I started to think, well, this might not be as hard as time travel or reliable psychic radio. Like this might be, AI might be something you can just sit down and program, and that started to seem very interesting, and set me on the path I've been on ever since. Although I haven't yet created the human level and superhuman thinking machines that I'm after. I think the field has certainly progressed considerably since the late 1970s.
yeah, and I know what you mean. As like the first, my first introduction to things of AI nature and robotic nature, it was two separate things. Was like at the Buell Science Center in Pittsburgh when I was younger, and there would be computers like Texas Instruments and Commodore computers that have the basic. It wasn't really AI. It was just kind of like the computer could respond to human inputs, but it wasn't smart. And then there was a separate thing like a pet computer with a robot arm hooked up to it, but they were two totally separate things at the time. And now over time they seem to kind of like merge together. AI and robots have a lot of things there that can work together. And I also read the Robert Heinlein books from the late 1950s and early 1960s. I was amazed by the technology described there, that we can't even make some of those things at the time. And from Asimov, where he brought together some series that turned into like iRobot. Okay. And that's where, when I first saw Sophia, I was like, oh my gosh, it's Sunny from iRobot, but it's Sunny's girlfriend or something. Hey, did you ever see that movie, iRobot?
I did not see the movie, to be honest, although that was based on the short story collection by Isaac Asimov, which I read as a kid, and I've seen bits and pieces of that movie somewhere or other, but I never sat down and watched the whole thing. Yeah, that was Will Smith, right? But I mean, the Asimov iRobot stories, those were interesting and inspiring, and I mean, they were focused on sort of a robot psychologist who was there to diagnose all the problems with intelligent robots. And certainly it was a more thoughtful approach to robot ethics than one sees in the Terminator or something like that.
Yeah, and I saw you did that podcast with Marco Guerra and Nick Stahl from the Terminator 3, and it was
I'm getting a very brief interrupt from my 3-year-old son. Give me a moment.
That's okay. I got to adjust the audio while we're at it. Good, take care of that, and I'll check with my audio techs. I brought my audio down to 12 o'clock. How's it sound at this point? Let me know in the chat.
I've been summoned to find a Peppa Pig balloon. I have now found it. So.
Hey, Papa, how you doing? Have him come on the podcast too.
The heart balloon seems to have lost its string.
People were asking about the that's a robot over there. Oh, is it somebody's birthday?
It is nobody's. Well, it's always somebody's birthday, but it's nobody's birthday here.
Okay.
That lost its string. Maybe Mama can find another string for it. I wonder where the string went. If you let it go, it will boom up to the ceiling. Or should I tie it on the same string?
Yeah. So we can have double string.
Yeah.
Then we will have double one.
All right.
So while Ben's sorting that out, what I'm going to do is I'll drop over in the chat. I've got a link to
All right, here we
Sophia.
are. I've
That's all right.
solved an urgent problem regarding 2 helium balloons. Now I'm back to other forms of technology.
There you go. You know, that's a lovely thing about kids. You know, it doesn't matter if you're doing a podcast. They need dad or grandpa's help. It's like, hey, I need this
Yeah.
balloon.
That is my 3-year-old son. His name is Corxi, QORXI, which stands for Quantum Organized Rational Expanding Intelligence. And
Oh my gosh.
his little sister, who's 2 months old, is Xorchi, XORQI. So there's sort of the category theoretic duals of each other. But she's too little to crawl in here now. So.
That is the most creative name I have ever heard. That is amazing. Corxi.
Corxi.
Oh, that's fantastic.
We got QORXI and the little sister XORQI. So far they haven't confused each other with each other. We'll see.
Okay. Has he learned to spell it yet? Is he
yeah, it's easy to spell,
practice?
actually. He doesn't realize it's unusual, actually, Tim. It's just his name, right?
Yeah. He's used to it. He's had it all his life.
Indeed. Yeah.
He has it all his life. All right. So what as we were talking about things like with Isaac Asimov in the early days, and there was one thing with the 3 laws, and that came up also in iRobot with Sonny as it relates.
You remember that? You remember the 0th law? Did the 0th law play a role in that movie?
I don't know if there was a 0 flaw, but I think Sonny had a little extra special cognition abilities over the other robots. So I don't remember if that one did, but the 3 laws, there was one: a robot may not injure a human being or through an action allow a human to come to harm. Right. And are these real? Are these 3 laws real? And does Sophia use them?
Well, no, I mean the 3 laws of robotics were made up by Isaac Asimov in his novels, right? And I mean, in a way they were made up to be broken, because they were made up to be good fiction, right? So I mean, in Asimov's stories, the robots obeyed these 3 laws, and then he explores the various flaws in this scheme and the way robots go amok anyway, right? So I mean, yeah, the first law was the robot shouldn't hurt people or through inaction let people get hurt. Second law was the robot must obey people, except where obeying people would conflict with the first law. Third law was the robot should protect itself, as long as that doesn't conflict with the first and second law, right? So it's like, don't hurt people, obey people, and protect yourself in that order of priority. And what Asimov explored in his stories is how there, as with any legal code, there are so many edge cases and weird situations that it doesn't work very well. In some of his later novels, he added a 0th law, which was the robot should not allow humanity as a whole to come to harm, which it makes it even more complex and confusing, right? And I think the main lesson to draw from this in seriousness is ethics cannot be rule-based. And everyone who's been to 3rd grade knows this, right? Like, if you give kids exact rules to follow, they will find some way to obey the letter but not the spirit of the law and do something screwy anyway. So I mean, getting an AI to be ethical can't be about laying down exact rules for it to follow. Once you have an AGI 10 times as smart as humans, it's going to figure out a way to use the letter of your law against you, right? I mean, the ethics has to be about the AI getting the spirit of human culture and human ethics and having genuine compassion for human beings. And once you have compassion for humans and an intuitive feel for human culture and ethics, then you can use a list of rules as a sort of guideline, right? But the list of rules can't be the main thing. And of course, Asimov himself realize that, which is one of the points he was getting across with these stories, showing how the rules break and the rules don't work. So when you look at something like the Sophia robot that my good friend David Hansen developed, or the Grace robot we're developing now through our partnership with Hansen Robotics, Awakening Health, which is elder care focused. I mean, the main focus David Hansen has had in terms of robot ethics and AI ethics is compassion. Like, can you get AI and a robot to genuinely feel compassion for human beings? And if you can do that, then you can work on the specific ethical rules and procedures. And if the ground of compassion isn't there, then you're screwed, right? And this is one of the motivations I have for putting AI and blockchain together, because I feel like if the world's AI, as it advances from narrow AI toward full general intelligence, if the world's AI is controlled by a few military and intelligence or advertising companies or Wall Street trading firms, you're not likely to see compassion as the core principle. And humanity at large has a lot of compassion in it, but the more compassionate parts of humanity are not necessarily the ones in charge of the largest amount of resources and data sets and computers. So if you can make your AI decentralized and democratic, so the whole of humanity, including, say, the whole population of Africa is one example, the whole of humanity is contributing to growing and teaching this AI, there's more chance of getting a compassionate heart, so to speak, in your AI. And I think Asimov would have been down with this, but in the end he didn't go that deep. And of course he passed away before AI started to get so real.
Yeah, before it started coming to life, because there's some forms of things that appear to be AI, but they're not. They're simply decision-making process in response to stimulus, like video game NPCs. That's not really an AI, but entities like Sophia, she's learning how to paint. And the last I read, that she was actually learning how to make NFTs. And I don't know if she's learning how to program, but what else has she learned? She learned how to paint, and I saw some of her paintings that were posted online.
Yeah, Sophia has she can move her arm and make paintings, and also many of the neural nets and other software programs underlying her software can generate art. So the NFT sale that we did with David Hansen and Sophia and Andrea Bonacetto, this was an interesting collaboration where we had Sophia drew some things, Andrea, who's a human artist, did some art, and then the neural net algorithms that were related with Sophia's mind transformed all the artwork in some way. So it was definitely a cyborg art form, so to speak. It was a mix of human, robot, and AI algorithm contribution. And I think we're going to see more and more of that occurring in various forms. And over time you'll see more like profound fundamental creativity coming out of the AI side. I think what happens now, AI can create amazing things and humans are selecting the best among them, so that there's a human aesthetic judgment that the AI doesn't yet have. But I think it will grow that. But then there may be a difference between what the AI finds a great work of art for its own aesthetics and what the AI guesses a human will find the best work of art for its aesthetics also. I mean, just like the great jazz musician who plays something very abstract for his own taste and then writes a pop song to make money, right? So the AI may keep its best works for itself, and we'll look at them and be like, what the hell is that? Then it gives us something we think is a masterpiece, but it thinks that's like a kindergarten exercise. So it's going to be very, very interesting to explore AI in visual arts and in music and in theater, in literature. And again, I think this is an important part of AI coming to grips with the heart and soul of humanity and developing true compassion and openness to people. I mean, the NFTs are a great thing in terms of creating new business models for human creators and then ultimately for AI creators. But the really profound thing behind there is computational creativity and joint human AI creativity, because I think this is part of how we create a benevolent singularity where humans and AIs are creating each other together as they create works together. But then this ultimately, this also pertains to like nitty gritty issues relating to different blockchains, right? Because NFTs right now, they're very wasteful of resources, and they're needlessly expensive in their infrastructure. And running NFTs on Cardano is going to be just a lot less destructive to the environment and a lot less wasteful of resources. And I know there's teams hard at work now in getting Cardano based NFT infrastructure. So I look forward to all that coming together along with putting SingularityNet AI platform on Cardano blockchain, which is currently underway as well.
Yeah, I've read about some of that. For example, if you were to running an NFT on Ethereum uses about 2 households worth of energy per day, whereas you run it on Cardano, I think it's immeasurable. I tried to figure it out. I can't figure it out. If someone can figure it out,
I
they
mean,
can let me
it's
know.
very small. I mean, because there's no reason for these things to be expensive. Just like there's no reason gas costs should be so insanely high on Ethereum. I mean, or transactions are now slower and more expensive on Ethereum than there's any good computer science reason for them to be, right? It's just, the system was not designed for the level or type of utilization that it has now. And it also wasn't designed in an elegantly enough modular way to be easily enough updated in place. I mean, I think, Ethereum was landmark achievement. I mean, it's amazing that it was put out when it was, and it has changed the world. So everyone involved in creating Ethereum should be like, they should be patting themselves on the back that they created something amazing. But
Yeah.
I don't get the feeling that Ethereum is the technology for the ages, right? I mean, I think like in the operating system space, for example, Windows is not a technology for the ages. Linux maybe, and part of it is that Linux is elegantly modular, and you can update and improve all the different parts without breaking the whole thing, right? And I think Cardano has a similar sort of high quality design and modularity property.
Okay. Yeah, that's what I noticed with Cardano. You do get the layers and the modularity, and the ability to upgrade one piece without breaking all the other parts is one of the keys to being able to do that.
Yeah, I'd
And
say the biggest challenge I see is, while Haskell is an amazing language, the community of developers who like both Haskell and blockchain is not that large, right?
Mhm.
So I think you're going to see more efforts to enlarge the developer community, so that more and more things can be developed at greater speed. But at the same time, you can use the layering to reduce, though not eliminate, the need for a huge army of Haskell developers, right? So when we port SingularityNet onto Cardano after Plutus is out on mainnet, I mean, you can make an AI agent running in Python or whatever language you want. It's wrapped in a Docker container, which is then running on Cardano blockchain in a sense. But the AI developer doesn't have to know anything about Haskell, right? So I mean, using the multiple layers, of course, not everyone contributing to Cardano ecosystem has to know the language that's used in the guts of Cardano. I mean, just as say in the AI field, people write Python code using the TensorFlow AI framework. There may be C++ or Go or C or other languages deep under the guts in TensorFlow, but I mean, with a well-layered design, the average programmer / user doesn't need to know that underlying language. So I think the multiple layered and modular design, it has made some things take a little longer in the early stages of Cardano software development, but I think it's going to pay off big time during the next phase.
Yes, and just so people know, The KEVM and LLVM technology has been a work in progress for a long time. Runtime verification is back on the KEVM part of it. And we're talking later 2021, the latter half of this year, Q3, Q4 timeframe. You'll start seeing components of that deploy onto the mainnet. And I mean, I'm not going to commit to a
very
particular
cool.
timeline. That is just my estimate based on what I'm seeing and reading out there on the internet from the developers on Cardano. So multiple languages coming soon. The last Cardano 360. If you want more information, check out that last Cardano 360 from the end of March. That one had a lot of information on this kind of stuff.
That should be cool. Yeah, I know. As one example, once you get LLVM, then Christian Schaffmeister, who's a friend of mine who does computational chemistry out of Temple University, he's got a common Lisp library for nanotech simulation, which is compiles to LLVM, right? So you got on-chain nanotechnology. There's a lot of amazing stuff that can be done here.
Yeah, it's almost hard to comprehend what all for me anyway, or what all can be done with it. So, so let's. I want to go back to Sophia for a minute about how she thinks and how her brain works and stuff like that. And there's a few questions that have come up in chat, kind of along that lines too, because people find her very interesting. She's human. She has a human appearance, a pleasant appearance, and she can speak clearly in English language. But so how powerful is her brain, and how much of that runs on board local on the robot, and how much of it is out there in the world where she has to access either Wolfram Alpha, Google, Siri, some other data source?
So the first thing to clarify is the relation between a robot's mind and its body is not one-to-one like with a human. Like, I've got this bag of meat here called Ben Goertzel, and there's one brain inside this skull cage, and swapping it out would be a very painful and laborious operation, right? Which I haven't undertaken yet. On the other hand, a robot like Sophia, I mean, she can run a whole bunch of different software systems. You can load different software to control her depending on what you want to do. So Hanson Robotics, sometimes humans just tell her what to say. If she's giving a speech or something, she doesn't necessarily make up that speech. Hanson Robotics has their own Hanson AI system, which mixes neural nets and human coded content in a certain way. I wouldn't say it's an advanced learning system, but it's a multi-component AI system, and they have plans to develop that in the direction of advanced learning. On the other hand, sometimes we have run the Sophia robot on OpenCog AI systems, which have a more sophisticated cognitive architecture behind them, with pieces running on Singularity Net platform. On the other hand, from talking to Sophia briefly, you can't always tell which AI system she's running, right? Because they all can hold like very basic conversation, but if you ask deeper questions, then there's a big difference between Hanson AI system and say the OpenCog Singularity Net system. So that's we've been building a whole new AI dialogue system for the Grace robot, which is Sophia's little sister, being developed in the Awakening Health joint venture, which is aimed at elder care. And we're then going to take this OpenCog / SingularityNet based dialogue system we're developing for Grace. We're going to take that, sort of remove the medical specific parts, and roll that out for Sophia within another joint venture called Sophia DAO, which is another JV of SingularityNet and Hanson Robotics. And we look forward to rolling out that AI dialogue system for Sophia DAO on Cardano platform as well. And this is going to be, open source and oriented toward compassion, humanitarian, and arts applications. And so we've got a project called the Sophia Bus, where we're going to have a bus travel around sub-Saharan Africa with a bunch of computers and robots on it, stop for a couple of weeks in a village, and then teach programming and robotics, leave some small robots and tablets and stuff behind for the kids, then go on to the next village. So there's which will be a Sophia DAO project. So there's a lot of interesting things you can do with these robots, but you do have to be careful, because from the front end you can't actually tell what's in the back end. And I see people's impression of these robots is all over the map. Like, some people think they're much smarter than they are because they look like people. So the robot says hi, and you think it's a genius, right? Because it looks like a human. Some people think they're much stupider than they are, and they're just chatbots, which is not true. We have some real deep learning and reasoning systems behind there, and we have code that allows the system to respond quite sensitively to the look on someone's face and where their eyes are moving. And we know we used OpenCog running on Sophia in 2018 as a meditation assistant, and to help lead people through visualization and deep listening exercises. And we found a number of people were put into quite profound trance states by their interaction with the robot, and found it to be transformative experience. So it's very, very fun as a way to interface between this sometimes abstract world of AI algorithms and structures and the human world, where a robot that can look you in the eyes and smile, mirror your facial expressions, and have a chat is something that everyone can relate to. I mean, I don't think this can or should be the only interface between your advanced AI systems and the human world, but it's fantastic to have it in the mix.
Wow. And, I saw in the description of your podcast with Marco and Nick Stahl, you guys are talking about how a robot like Sophia, or any AI, not the robot, but the AI, can communicate with other AIs in a decentralized, democratized environment and reward each other for information. Do they have a way to validate that information or intelligence-based decision making is valid? I mean, what can you tell us about that? First of all, how does that work? Like, they can negotiate with other AIs to gather information.
Well,
How does that work?
there's no magic bullet, but you can have AIs cross correlate information from many different sources, and you can then ongoingly check and update the veracity of many different sources. And I think the AI has the advantage that it's not emotionally driven like people are. So I mean, when people see news they're inclined to believe, they don't check. And when they see news they're not inclined to believe, they do check, right? And the AI could be that way, but we haven't taught or engineered the AI in that way. So I mean, the AI, we're sucking down all the news, we're sucking down research papers. These are going into neural models. They're having semantics extracted from them into a logical reasoning engine. And so when an AI reads something, it can be checked against what's extracted from a whole bunch of different sources. And what's extracted from each information source can be cross-checked against other information sources. So you can identify which information sources have a higher veracity about which type of news and which type of scientific information and so forth. So I mean, I think in that way you can do a better job than any human is going to do, because no human can read that much, and so a human can't form such a grounded opinion of the veracity of different sources. But still, it's not a magic bullet. Like, I mean, there's going to be some questions where the real data isn't there online anywhere, or there are high quality sources that have conflicting opinions, and the most we can hope for there is that the AI can flag those situations for what they are, right? And say, well, about this stuff, I don't know. And if the AI knows what it has a high probability about and knows what it doesn't know much about, I mean, then it's way ahead of most humans, right?
Yeah. Yep. I've done that before, where I was looking up a dietary supplement, trying to make a decision, and I looked it up on, I think it was Harvard Medical, WebMD, and a third source. and all three sources gave three different answers. One was to the no, don't, it doesn't do anything. One said the results are unknown, and one said the results are positive. And I just said, well, I guess I'm back to square one. I'll just try it and find out what happens. But AIs may be able to maybe sift through that. I don't know. Ben, I was curious. Have you ever seen an AI figure something out that you hadn't expected to happen, or started doing something like it has code that has it do one thing, but then something occurred and you're like, wow, we
I
didn't
mean,
anticipate.
that happens all the time. I mean, of course, we're using AI for genomics research. So I mean, then the whole point there is the AI is discovering and uncovering stuff that you didn't expect. And I mean, you're looking at genes and pathways that people haven't necessarily studied that much. So I mean, as one example, a long time ago, we had AI studying data regarding the genomics of people with chronic fatigue syndrome, and we're looking at DNA samples from blood, and the AI is just pointing out all these genes and pathways to do with the brain, and we're like, well, why is it telling us all this brain stuff is what's driving chronic fatigue syndrome? Didn't make sense. But then after enough investigation, we realized, there was a hypothesis out there that lesions in autonomic nervous system are what's dysregulating endocrine system and skeletal muscle tissue and causing chronic fatigue syndrome. So that totally was not what I would have been looking for, nor what the biologists in our team would have been looking for, but it resonated with something some other physicians had said at some other point in time. So that's a scientific discovery example. But anyone who's looked at AIs to play games, though, you've seen many examples of this. Like AIs are really good if you put them in a game context, and you tell them, okay, your goal is to get a maximum number of points, or to go get that jewel that's over there. I mean, the AI is going to exploit the peculiar properties of that game world in ways you never would have imagined that it would. It's gonna find strange pathways to get from point A to point B, or build weird looking structures that no human would imagine, but that are allowed according to the physics of that game world, right? So looking at, say, we've been exploring OpenCog system to build stuff in Minecraft, just as a playground for having multiple AI agents cooperate to do things, right? And if you want to get the AI to get some far off object in the Minecraft world, AIs can construct some very surreal structures as bridges and routes to get from one point to another, which are interesting architectural works in themselves, because the AI is just thinking about what are the rules of Minecraft. It's not trying to use analogies to in our physical world, right? And so I think actually AIs are surprising and creative all the time. I think what AIs still can't do yet is choose which of their surprising and creative products are the best or the most relevant to our world. Like, we're in the science context, like we're using AI to make cool suggestions, but then a human being is still like choosing among those suggestions and running experiments based on it and so forth. Like the bottleneck isn't so much creativity. The bottleneck is understanding of the broader context into which the creative productions fit. And that's what we're working on in the artificial general intelligence research component of what we're doing. I mean, in Singularity Net which is a project I'm leading. I mean, this is a decentralized platform for AI, which just lets diverse AI agents coordinate and cooperate together at scale. And Cardano is an amazing infrastructure for this, allowing the decentralized coordination to work. Then what you can do with that is quite diverse, right? You can put AI agents on this platform to control a robot. You can use AI agents on this platform to to do, say, genomic research, or you can use AI agents on this platform to try to make a real general intelligence that can really think like people, which is what we're doing in the OpenCog research initiative. And SingularityNet, we're trying to foster all of these things. And I think one of our big challenges in the next phase, as we roll out the platform on Cardano, is to pull more and more third-party developers and users onto the platform. And I'm hoping there can be profound synergy there with the Cardano community, leveraging this synergy on the technical level. We need a synergy on the outreach level so that we can pull more and more users and developers into this whole decentralized and decentralized AI ecosystem, because there's too much stuff to build here for like the SingularityNet and Cardano teams to build all of it, right? And there's a lot of people out there in the world who get our visions and want to help. So the hope is that by putting the right tools out there, I mean, Plutus being among them, and the new versions of SingularityNet and OpenCog being among them, by putting the right tools out there, hopefully we'll be able to catalyze a much larger community to join us in like building the next generation of the world's tech infrastructure on a decentralized basis.
Yeah, that'd be great to have people join in that. Like, for example, you were saying with the decentralized AIs, one AI could be the product creator that creates something or that develops something using artificial intelligence, and another AI assesses it and says, is that something of value? Would a human like it? And I'm assuming you need human trainers as well to train the AIs so that an AI can create and another AI can assess.
I mean, to the
and
extent
all
you
these
can do
different-
implicit training rather than explicit training, you'll be better off, right? So say with the Awakening Health elder care robots that we're rolling out shortly to provide nursing assistant functions in various elder care facilities. I mean, we've got enough functionality in there that they can deliver value, but then as they watch a nurse interact with a patient, they're learning from that, right?
Okay.
So they're getting their on the job training by watching what people are doing, and then of course when they say something to an elderly person, they understand what reaction they got, right? So they can see what works and what doesn't. And I
And
think
then
this sort of interactive experiential learning is going to be more valuable than explicit training. So I think there's a lot of AI neural net models out there now that need explicit training data curated by human data scientists, but I don't think that's going to get us far enough. I mean, we need experiential learning as the basis, and once the experiential learning is there, you can do some training on top of it, but it can't be the base. It's sort of like our discussion a few minutes ago on the Asimov's laws of robotics, right? Like once you have a basis of experiential ethics and compassionate connection with people, you can give ethical rules as further guidance. And similarly with learning how to do stuff, once the AI has learned by its experience how to do something, you can then give training and lessons as guidance. But the experiential learning has got to be at the base, and I think that's part of the reason why in the first decades of the AI field, not that much practical progress was made, just because you didn't have the sensors and actuators, and you didn't have the processing power to drive that experiential learning. But we have that now.
And as the AIs learn this, let's say Gracie learns something that is good and something is bad, she can transmit that information to other AIs
Well,
for
that's the
trial and
other beauty of it,
evaluation.
right? Like
Yeah.
once I spent a long time to learn, say, how some bit of math, how category theory relates to Galois connections or something. Great, that's in my head. If I want to teach that to you, I've got to use like pencil and paper and sound waves through the air.
And
I can't just
repetition.
beam that hunk of brain stuff into your brain, right? But AIs can do that. Of course, it's not trivial. Like even if I could beam that into your brain, you might not have the mathematics grounding to accept that beam of thought stuff. On the other hand, some people would, right? So I mean, and you have that problem among AIs also. Of course, you can't take everything one AI system learned and just port it to a different AI system, because there may not be the connectivity between their knowledge bases. But if you architect things right, yeah, you can make it so a robot has its own knowledge and its own experience, some of which may be private and can't be shared because it's private to the people it's interacting with, some of which may be specialized. But then the totality of robots also has a sort of group mind, like a digital collective unconscious, which is updated based on what the individual robot has learned, and which can then be transmitted to other robots, right? And I think you have a great deal of flexibility, right? Just as a robot could run many different mind systems on many different times, the robot can have some knowledge which is personal to it, and some knowledge which is shared with other robots, some knowledge which is shared with other non-robotic AI systems. I mean, just like with smart contracts, whatever you can code can be done, and that's an amazing thing about engineering mind systems. Whereas us evolved systems, we're not modular, we're not well layered, we're not designed for self-modification. So even if we knew everything about how the brain works, to like open up the head and rewire stuff is going to be much more of a challenge.
Yeah, the possibilities are infinite. And so between the Sophia DAO and the Singularity DAO, this enables people out there in the world who are working on AI now to be introduced to the Singularity DAO and start building AI that is compatible
Well,
and communicates,
you're
right?
confusing terminology, but in a good way that lets me talk about another project of ours. So we have
Okay.
Singularity Net. Singularity Net platform is our decentralized AI marketplace, which we're in the process of porting to Cardano. Sophia DAO is an open source project aimed at bringing Singularity Net AI to the Sophia robot, together with Hanson Robotics' Hanson AI. Now, you use the term Singularity DAO, which is actually a separate project, which is a decentralized finance project, which I wasn't even going to talk about today. But since you mentioned the name, we're actually doing a bunch of interesting things with Singularity DAO. I mean, Singularity DAO is actually aimed at using decentralized machine learning and AI for on the altcoin markets. So I mean, Singularity DAO uses Singularity Net AI for portfolio management and trading of baskets of altcoins that are held by various individuals. And this is another thing that will end up on Cardano platform eventually post Plutus. And our goal here is to turn the sort of universe of smaller altcoins, like representing coins of early stage projects, into a really vibrant, flourishing and mature financial ecosystem. So as we get more projects rolling out on Cardano native assets, it'll be really cool to have a Cardano based version of Singularity DAO, where AI is being used to trade and arbitrage between different baskets of native assets. So this is an Ethereum thing for now because we don't have Plutus yet, but we're doing a governance token generation event for that next week, and then a public sale of governance tokens on maybe May 10th or something. So this is, again, the gas costs of Ethereum are very bad for a project like this. On the other hand, it's what we have to work with right now, and having Plutus out there for a project like Singularity DAO is, along with so many other DeFi projects, is going to be absolutely instrumental. And I think we're all really looking forward to that. So yeah, the Sophia DAO, Singularity DAO. Then we talked about medical work. We talked about AGI R&D. All these are things you can do on the same Singularity Net decentralized AI platform, which soon will be running on top of Cardano, right? And so this is really, it's building the world's computer, right? I mean, we're trying to build a new infrastructure for the world's software technology, which has blockchain at the base and which has AI deployed in a way that allows AI to infuse every application built within the infrastructure.
Yeah, where AI is one of the layers interacting with the blockchain and the users and all that
Yeah, and I
stuff.
think you're
That's
going
a
to find that AI has a role to play in essentially every application, right? I mean, there's not many software applications out there that don't need more intelligence in one way or another. Once you have a large scale, low cost, decentralized AI implementation, which is what we're going to get with the full scale integration of Singularity Net with Cardano.
yeah, and so that sounds like the Singularity DAO's a much more advanced, intelligent version of a more so than a simple trading bot that runs on an exchange.
Yeah, I
or
mean, AI has been used in traditional finance for quite a long time, and you have, say, the world's most successful hedge fund, the Renaissance Technologies Medallion Fund, has been AI based for decades, right? So in the crypto space, AI has not been used as much, and that's partly because it's just a less mature market. It's partly because crypto is so crazy, and the historical data is going to be different than data going forward. So that more naive approaches to AI pattern recognition just will overfit to historical data and won't work well in a crypto context. But if you make a few steps in the direction of general intelligence without getting to full-on human level AGI, just a bit better transfer learning and generalization ability, I mean, then you're able to get AIs that can handle crypto markets better. And we're playing with that on the back end of Singularity DAO.
Wow. The technologies are amazing. There was two other things we were going to touch on this podcast, and we'll wrap up. I know you've got other things to do, and but I could just listen all day. So Ben, one of them was if AI meets a quantum computer. So if you take a quantum computer that can do an infinite number of calculations, right now it's not sufficiently powerful enough. The most powerful quantum computers are maybe a little more powerful than a desktop, like one made by IBM. So, but let's say you have this very extremely powerful quantum computer and it meets a very intelligent AI. What could be some of the benefits and drawbacks of putting those two things together?
Well, I think quantum computing can be very beneficial for AI. I mean, I think the first implementation of that will be something like a QPU that you plug into a server like a GPU, right? Where you'll have a quantum computing plugin which allows some things to be done much more efficiently than can be done on the general purpose CPU. And there's a whole literature on what algorithms could run very well on quantum computers once the hardware is there. I mean, I think I gave a talk, I can't remember when, it would have been 2003 or maybe earlier, on quantum evolutionary computing, how you do genetic algorithms on quantum machines, and the probabilistic logic framework that we use in our OpenCog AI system, which is rolled out on SingularityNet. Probabilistic logic networks, you can replace all the real number probabilities with complex amplitudes, and you've got quantum logic reasoning, right? So, I mean, I think the math is there, the algorithms are there, we need the hardware to be there, and then you can have various learning and reasoning algorithms running on quantum computers as components within a broader digital computing network. And I think that's where you're first going to go. Then, of course, eventually you'll get full-on large-scale quantum Turing machines. Then you can run your whole AGI system in the quantum computer. And the nature of quantum computing, as currently understood, is you can't compute anything different than what you compute with a normal classical computer, but you can compute some things much, much faster. And so you could get substantial acceleration of many cognitive operations. And I mean, we could go beyond quantum computers eventually. Who knows what we're gonna get? I tried to work out once how you'd build a femtocomputer inside a quark gluon plasma by networking together quarks and gluons. the thing is, we've never created a quark gluon plasma that lasted longer than a fraction of a second, right? So there'd be some minor engineering difficulties in actually building the thing. But I mean, I think once we get an AGI that's 10 times as smart as any human being, maybe it'll figure out how to stabilize a quark gluon plasma. We'll all mind upload ourselves in there along with the femtotech AGIs, and that's where the crypto conventions in 2040 will be held. So I think there's incredible number of possibilities. We're going step by step. I don't think we need quantum computing to get to human level AGI, but as soon as we have quantum computing hardware that adds practical value to classical hardware, we're going to be the first ones figuring out what can be done with it. I mean, quantum cryptography, I think, will become a practical thing well before quantum AI, because it needs fewer qubits. I mean, it's less demanding on the quantum hardware, but that's a whole other topic.
Okay. Well, maybe that's another topic we could explore. And, I look forward to Charles will be doing a podcast or maybe an interview with Sophia sometime in the future. We don't know when, but at some point, I think someone's going to do an interview or with Sophia. Isn't that correct?
Yeah, we've been planning that out. I think the scheduling has not gelled together yet, but I'm looking forward to it. Yeah.
Yeah. Oh, that's going to be cool. I'll make sure I tune into that as well. All right. So the last part you started to touch on there, sometime in the future, around the year 2040, 2045, an event called the Singularity may occur. For viewers not familiar with that, the Singularity, at least the internet says 2045. What do you think, Ben? When do you think the Singularity occur?
I think we could make it happen a lot sooner than that if nothing goes wrong. But I mean, I think the notion of the singularity is a point in time at which progress is occurring so fast it appears to be infinite to our silly human brains, right? And I mean, I think as soon as you get an AGI that's twice as smart as people, you're very close to a singularity if you want to be, because that AGI can then revise its own source code and help create new hardware for itself, and you'll get a recursive self-modification trajectory. So I think that's exactly how far off it is a fool's game to give exact numerical estimates. But I mean, I think for what it's worth, I think we could be there in 3 to 5 years if there was a sufficient focus of resources on it, which is not happening right now. I mean, the globe is putting trillions of dollars into technologies for people from one nation to kill people from other nations. The globe is not putting trillions of dollars into creating beneficial, decentralized, artificial general intelligence. So humanity is not putting a full-on push on creating benevolent AGI, nor on curing death, nor even on stopping global warming or feeding the poor in Africa, right? So I mean, we're clearly doing the things that are really important, sort of along the margins and edges of figuring out how to kill other people and sell people useless junk they don't need and rip other people off on financial markets. So given humanity's current profoundly flawed and demented global resource allocation, it's hard to say. It could be 10 years, it could be 30 years, but in a historical sense, we're almost there, right? I mean,
Yeah,
which is an amazing thing to realize. Like we are near the end of the meat era of intelligence on the planet, and whether it's 5 or 30 or 50 years is almost irrelevant in the grand scope of history, although quite relevant for our own individual lives and for our technology projects.
wow. Okay, so last question, we'll wrap it up for the day. Thank you, Ben. And that is, where do you want to be when the singularity occurs?
Oh, well, I want to be a lot of places at once, right? So yeah, I'm going to wait for a few more software updates, but I'd be very happy to have my mind sucked out of my brain and mind uploaded into OpenCog on Singularity and on Cardano. Then my brain is on the blockchain, right? So
That's
yeah,
a big blockchain.
But I don't want to annihilate my human body either. I want the non-destructive upload, so that the meat Ben is still here, and the global decentralized uploaded Ben is up there in the noosphere, right? So I mean, why do we need to be only in one place? Right?
I love how you put that. The meat Ben is still here. Okay, that's probably the Ben that cares the most. Yeah, I kind of like being here.
Well, you haven't
Oh,
tried the alternative yet, so yeah.
yeah, we don't know. We don't know. I've only seen it on strange episodes of Black Mirror where they
So what if your
explore
mind
the.
upload says, "Wow, man, this is a billion times better. Don't bother with that lame old meat existence." Will you
It,
will you believe it and just off yourself or not? Yeah.
that's a good question. That's kind of like the things that could be explored. Uploading a brain, and then the uploader version says, "Yeah, I don't need the meat. I don't need the meat bag anymore. Go ahead and get rid of it." Well, which one do you go with?
At
Those
the
will be
moment,
ethical
I don't
questions.
see why it has to be either or, right? I mean,
Yeah.
but it's interesting to think about, and I think if you could get a sort of mind meld going with your upload, where you could like directly sense what it was experiencing, you might be convinced that that's just a better way of doing things. Right?
It could be. Oh, look, I convinced the meat bag. But the problem is centralized artificial intelligence people will figure out a marketing angle, and they will unleash the power of AI on marketing. Or they already have. So we
Well, yeah,
don't.
this is one of the worries you have, right? Like you're going to get brain implants, and the brain implants are going to have ads, right? So then you have a craving for that Dunkin' Donuts donut, and it's like, do I really want that donut, or is that the adware installed in my brain? And why did I really start to love the Republican Party so much, right? So
Yeah.
I mean, yeah,
The,
this is why we need decentralized AI to become the norm before we get the transition to true general intelligence and brain computer implants and all this. I mean, otherwise, we're going to get some very twisted things happening. I mean, there's already very twisted things happening all over the planet, but there's the potential for it to get even worse.
yeah. So that I guess that brings us to the end question here. Do you want Sophia and Gracie, or do you want Hal 9000? Now, I think I'll take my chances with Sophia and Gracie at this point, at this juncture. All right, Ben, we're going to wrap it up for a day. There've been a few questions. People asked, we got to satisfy the curiosity about the doll. There's a doll in the background.
Yeah, I mean, PP, that doll is named PP, but she is a mystery that's not meant to be solved. So that's going to be left to speculation.
There you go. That'll be some other time, some other podcast. Ben, I look forward to seeing some of your future events coming out later this year. And you're welcome to come back over to Cardano Live anytime you want to have an update. You can hop on over here and give a quick update,
Right.
anything going on. And
Thanks a
we're going to
lot.
wrap up here. Ben, you can hang on the line.
Sure.
I'm going to switch it over, and we're going to roll out. Thank you, everyone. Please make sure you hit like and subscribe down below to boost the metrics, get more visibility to the podcast. And you can leave some questions in the comments. Check out the links in the description. It has the SingularityNet Telegram. We have Ben's Twitter, Goertzel.org website, and lots of information, resources in the description down below. Check it out. And while you're down there, smash that like and subscribe button. Thank you, everyone, for being here. Y'all have a great day, and look forward to the audio coming out later this evening or tomorrow. Bye-bye, everyone.